On the surface, it looked like a gracious compliment that a half-joking remark from Jensen Huang sent Marvell's stock price surging 30%, even sparking daydreams that Marvell could become the next trillion-dollar company. At first glance, it seemed like just another display of Jensen's social finesse. But in reality, that one sentence exposed an increasingly critical and urgent bottleneck inside AI infrastructure. Connectivity as GPUs multiply and memory capacity explodes, the true ceiling of an AI system may no longer be defined purely by compute or memory. IT may now be defined by connectivity. Put simply, connectivity is about how data actually moves. An AI data center is not a single GPU doing all the work, nor a single server. The AI workloads of the future will require tens of thousands, perhaps even millions of processors, all working in concert like one enormous computational engine. The question then shifts. It is no longer about how powerful a single chip is, but whether all these chips, memory banks, storage systems, and switches can be connected with enough bandwidth, low enough latency, and low enough power consumption. Think of compute and memory as the brain of AI. Connectivity is the nervous system that if the nervous system is not strong enough, even the smartest brain cannot truly work in sync. That is why Marvell has become so important. Marvell CEO Matt Murphy's presentation not only gave us a deeper understanding of the company's history, but also helped us peel back the layers of the principles behind connectivity. Who would have guessed that the connectivity giant currently holding AI data centers by the throat derived less than 10% of its revenue from data centers just 10 years ago, and that its most iconic design at the time was providing the Wi-Fi chip for the Barbie Dreamhouse? That fact actually exposes the most ruthless genetic rewrite in the company's history that a decade ago, Marvell was not the company it is today. Back then, over 60% of its revenue came from consumer electronics, and data center revenue was under 10%. Its most emblematic design was literally the Wi-Fi chip for Barbie's Dreamhouse. Yet it is precisely this stark contrast that shows just how thorough Marvell's transformation has been. After the current CEO took over, management made a decisive, gut-wrenching move. Marvell cut away consumer electronics businesses that were still profitable, stopped betting on any single product, and instead bet on the greatest growth cycle the semiconductor industry would see over the next 10 years, data infrastructure. The entire corporate structure was realigned toward that one monumental decade-long trend that at the time. Data infrastructure was not even a mature market classification, but Marvell gave it a crystal-clear definition. The future world would need a huge amount of semiconductor technology to move data, store data, and process data. That became the core of Marvell's decade-long transformation, betting on the entire data infrastructure era. The problem was that Marvell was not truly positioned on that trend yet. This was not a simple business adjustment. It was a complete reset of the underlying technological DNA, costing tens of billions of dollars, clearing out all historical baggage to get ready for the AI tidal wave. Management made an extremely decisive, even ruthless decision. They slashed a large number of businesses that did not align with the strategic direction, including consumer electronics units that were still making money, and completely reshaped the company into a semiconductor firm purpose-built for data infrastructure. The transformation was radical. Over the past 10 years, Marvell spent roughly $18 billion on R&D and made a series of acquisitions. Cavium, Avera, Innovium, Celestial AI, XCon, and others that filled the gaps in compute, networking, custom silicon, photonic interconnects, and scale-up switching technology. After deducting divestitures, Marvell effectively spent around $36 billion to re-engineer its own corporate DNA. Cavium strengthened its compute and networking capabilities. Avera helped it establish a custom silicon business. Innovium enhanced its high-end data center switching capabilities. Later acquisitions like Celestial AI reinforced its photonic interconnect portfolio, while the purchase of XConn added scale-up switching technology. Today, Marvell possesses a complete ecosystem spanning custom compute, storage controllers, CXL memory pooling, and long-reach and short-reach optical interconnects, making it a true connectivity giant. Yet if you look at the AI infrastructure bottleneck, connectivity is still the choke point holding back global AI data centers. The vast majority of Marvell's data center revenue comes directly from connectivity-related businesses. The company itself emphasizes that today the overwhelming share of its data center revenue is derived from connectivity. That is why Marvell is so special relative to NVIDIA. For a long time, the market fixated on the brain and the memory. NVIDIA is compute-centric, while Marvell occupies a unique position. It is connectivity first. IT is the only giant in the entire industry that has systematically built a massive moat around data movement. The reason it suddenly becomes critical in the AI data center era is not direct competition, but deep complementarity. NVIDIA provides a powerful general-purpose AI computing platform. Grace Blackwell, Vera Rubin, NVL72, and the future NVLink Fusion ecosystem, forming the core foundation of a supercomputing system. Marvell, on the other hand, is more like the provider of customized connectivity, silicon photonics, switching, and high-speed SerDes. For cloud hyperscalers that want to use NVIDIA's ecosystem while simultaneously developing their own custom ASICs or XPUs, Marvell can supply the crucial connectivity. Layer right in the middle. So Marvell does not simply compete with NVIDIA. In many areas, it complements NVIDIA. What is even more important is that back then, Marvell did not just undergo a business transformation, the IT also made an extremely risky technological bet. It leapfrogged from 14-nanometer and 10-something nanometer nodes straight to 5-nanometer, in the semiconductor industry. Such a jump is exceptionally rare. If it failed, the R&D investment would evaporate. But if it followed the conventional step-by-step path and waited for a 7-nanometer product, the market might already have moved into the 5-nanometer era, rendering the effort meaningless. Many companies choose to be fast followers, staying one generation behind to reduce risk. That strategy can deliver decent results, but it simply does not work in the AI infrastructure market. Because your customers are the wealthiest players in the world who demand the absolute highest bandwidth and lowest power. In the AI infrastructure market, there is no good enough alternative. If you are not in the top tier, the most elite customers will not even look at you. Being one generation behind means the overall cluster compute power gets dragged down and power consumption rises. Marvell's decision to skip 7-nanometer was fundamentally not reckless. If it had taken the conventional route and delivered a 7-nanometer product later, the market might already have lost its relevance. In the AI infrastructure market, not every player is even qualified to enter. You must earn the right to serve the AI data centers of the future. This is not a simple trend-chasing business. IT requires placing bets many years in advance. Why does connectivity become the next AI bottleneck? We can look at the evolution of AI infrastructure. Phase 1. compute.in. The early days, AI was constrained by raw computational-powered, NVIDIA's parallel computing breakthrough, with GPUs cracked the problem open, ushering in the AI era and making the company one of the most important AI chip players on the planet. Phase 2. The memory bottleneck. Models grew larger, parameters multiplied, and the explosion of large model parameters created an insatiable demand for extreme bandwidth and capacity that triggered the HBM supply chain boom. Phase 3 is right now. AI has entered the agent era. In the past, AI behaved like a chatbot. An AI agent is different. It needs to think, access long-term and short-term memory, decompose complex tasks, and distribute a task across a massive number of compute nodes for parallel processing. AI is no longer a single brain thinking independently. It is an entire organization collaborating at extreme speed. This computing model is not centralized. To visualize this intuitively, imagine an enormous kitchen. The GPUs are the three Michelin star head chefs. HBM represents the finest ingredients. The food running and scheduling system is the connectivity. On the surface, you might think you just need great chefs and great ingredients. But in the real physical world, if the food runners are too slow, the scheduling is chaotic, the chefs cannot communicate properly, or even fight over the same knife, and a chef might end up cooking the same dish multiple times, the entire system descends into chaos. In an AI data center, it is exactly the same. Even with the most powerful GPUs, if they cannot collaborate in real time, the system performance gets strangled by connectivity. The system ceiling is no longer determined by the performance of a single chip, but by the communication efficiency among chips, memory, and switching systems. IT becomes a competition of system-level collaborative efficiency. If we drill down further, the connectivity inside AI infrastructure actually spans 4 distinct physical distances. The first is kilometer-scale connectivity, the long-distance interconnection between different data centers. Today's large cloud providers operate many data centers across the globe. As AI workloads grow, a single data center may not be able to house all the required computing resources. Data centers must therefore be interconnected at high speed. But over distances of a few kilometers, tens of kilometers, or even hundreds of kilometers, electrical signals suffer severe attenuation. So you must rely on optical communication. The key technology here solves the problem of dispersed compute power, enabling multiple data centers to handle ultra-large-scale AI workloads collaboratively. This technology is called coherent modulation, and it also requires a DSP, a digital signal processor. Simply put, coherent modulation does not just send zeros and ones. Instead, it encodes complex data into the phase and amplitude of a light wave. You can think of it as imposing a complex cipher onto the light wave, and then the two ends use DSPs to perform high-speed decoding and error correction, ensuring the data remains accurate after long-distance transmission. This solves the long-distance connectivity problem between data centers. The second is meter-scale connectivity, the interconnection between different racks within the same data center, also known as scale-out. Inside a data center, each rack typically has its own switch, and those rack-level switches then connect to a higher-level switching fabric, forming the network backbone of the entire data center at this distance. One of the core technologies is PAM4. A simple analogy for PAM4. Imagine a light bulb that can only be on or off, representing two states. PAM4 uses 4 different voltage levels to transmit signals, much like a light bulb that can emit 4 different brightness levels, representing 0, 0, 0, 1, 10, and 11. This allows the data throughput on the same physical line to double. The core breakthrough is to combine PAM4 DSPs, high-speed analog components, laser drivers, and 100 terabit Ethernet switch chips on the same physical fiber to create a high-speed network fabric that multiplies data throughput. Marvell has a presence in PAM4 DSPs, high-speed analog components, and data center Ethernet switch chips. And it has also announced a 102.4T Ethernet switch chip designed for AI data centers. This layer solves the problem of high-speed cross-rack connectivity inside the data center. The third type is intra-rack connectivity. A prime example is NVIDIA's NVL72, which packs 72 GPUs into a single rack and connects them with extremely high bandwidth. The goal at this layer is full interconnect, meaning every processor can talk directly to every other processor. At this distance, copper cables still dominate today because copper is cheap, simple, and reliable. Jensen Huang himself has said, "Use copper whenever you can." But copper has an inescapable physical limit. The higher the bandwidth, the shorter the effective transmission distance to 200 gigabits per second. The effective reach of copper is about 2.5 meters, and a standard data center rack is a little over 2 meters tall. That means today's copper can just barely cover a single rack. But when transmission speeds hit 400 gigabits per second, physics dictates that the effective distance will be cut in half again. By then, copper may not even be able to cover half a rack. This is not a problem that can be solved by making copper wires thicker, because the real issue is signal loss and distortion at high frequencies. That is the so-called copper wall. The stronger the AI compute becomes, the higher the bandwidth requirement and the shorter the distance copper can travel. Ultimately, optical interconnects will be forced to move inside the rack. The fourth type is millimeter scale connectivity. Inside and at the edge of chip packages. It serves scale up, while also potentially influencing the future shape of switch chips and data center network topology. Essentially, it is optical interconnects pushing deeper into the chip package. This is the most cutting-edge territory. Co-packaged optics, or CPO. In the past, our understanding of optical communication might have been plugging an optical module into a switch panel. But CPO does something far more radical. It brings the optical connection right next to the chip package, so that fibers no longer just plug into the chassis, but sit as close to the compute chip as physically possible. Why do this? Because if the optical module is still plugged into the equipment panel, the data still has to travel from the core chip to the panel through a stretch of copper, and that copper stretch introduces massive power consumption, heat, and space pressure. The core logic of CPO is to convert the electrical signal into an optical signal as early as possible, letting the light exit right near the package and completely eliminate the loss from that last stretch of copper. This is extremely difficult to pull off. Chips are acutely temperature sensitive. You need to tightly bond a high-power switch chip with micro-optical components that are themselves extremely sensitive to temperature, all inside the same package. The chip generates intense heat under high load, while the optical components require ultra-high precision. This is not something you can solve by drawing a beautiful structural diagram in ALAB. It requires advanced packaging, silicon photonics manufacturing, and massive amounts of reliability validation to mature together. That is why CPO is not something Marvell alone can complete. IT also demands advanced packaging, silicon photonics, extreme precision in package stress control, and solutions to microvibration issues. That is why they invited the CEO of ASE to the event, which indirectly underscored the critical importance of CPO to advanced packaging and the entire Taiwan semiconductor ecosystem. At this point, Marvell's positioning becomes clear that Marvell's uniqueness lies in the fact that it does not just play at one point. IT covers connectivity technologies from kilometers all the way down to millimeters. Long-reach coherent optical modules, PAM4 optical interconnects inside data centers, high-speed SerDes, and scale-up switching technology within racks, and CPO with silicon photonics near the package. Each distance presents a different set of engineering problems, challenges, and supply chains, and Marvell's distinctiveness is that it has pulled all these capabilities together under one roof, attempting to become a one-stop supplier for connectivity in the AI data center. This also explains its relationship with NVIDIA. IT is not direct competition, but deep complementarity. NVIDIA provides a powerful general-purpose AI computing platform, while Marvell supplies the critical connectivity layer. In the middle, ultimately, all of this points toward a much larger vision, breaking physical constraints, shattering the ceiling of a single rack, and eliminating the distance penalty. The significance of optical interconnects is not simply replacing copper wires with optical fibers, nor is it that fiber transmission has zero latency. When photonics shatters the strict distance limitations of copper, physical distance still exists, but the penalty in latency and signal loss at extreme bandwidth is thoroughly flattened by optical transmission technology. More precisely, server rack and data center architectures used to have to be designed around distance. Physical hardware architecture dictated what was possible in AI model design. The reason so much was placed on the same board or inside the same server was largely because copper reach was limited. But if critical connectivity gradually goes optical, the architecture changes. Today, a scale-up system might connect 72 or 144 GPUs or XPUs. But if the distance constraint collapses, that scale-up domain might in the future be extended to 1,000 or even more processors. CPUs, GPUs, XPUs, memory, storage, and network interfaces would no longer have to be fixed inside one server box. The physical chassis disintegrates, resources are broken apart into pools, and based on the instantaneous workload demands of a large model, they are dynamically reassembled through a high-speed optical network. In the past, hardware architecture constrained the model. In the future, it could be the reverse. The model's requirements define the hardware architecture. Hardware follows the model. That is the real importance of optical interconnects. IT is not just about replacing copper with fiber. It has the potential to reshape the entire underlying system architecture of AI data centers. Through Marvell CEO Matt Murphy's presentation, we can clearly see the main thread of change in AI infrastructure. The core pain point evolved. Early AI lacked sufficient raw compute. So in phase 1 we focused on GPUs. Then the core pain point became compute speed far outpacing the speed at which data could be fed to it, creating a massive need to boost memory bandwidth. In phase 2 we focused on HBM. Now, the core pain point is how to organize thousands, even millions of compute resources into one perfect super dash machine. In phase 3, we must focus on connectivity, because AI needs to weave an enormous number of compute resources into a larger machine. In this phase, Connectivity will become the absolute protagonist of the competition. Whoever can move data more effectively may end up holding the most fundamental physical lifeline of AI infrastructure. That is what makes Marvell such a compelling company to watch. IT is not the most dazzling AI brain, but it is attempting to become the nervous system of the AI data center. And when the AI race shifts from piling on more GPUs to getting massive numbers of GPUs, memory modules, and storage units to work together like a single machine, connectivity is no longer just a supporting role. It becomes the core of the next wave of AI infrastructure competition. Marvell stock has surged nearly 130% year-to-date. The catch is that, unlike NVIDIA and AMD, it is not standing in the spotlight. IT does not sell the most glamorous AI brain. Instead, it sells the connectivity, switching, optical interconnects, and custom silicon hidden deep inside the AI data center. Yet it is precisely this company that recently released earnings and sent an extraordinarily strong signal. Marvell's CEO noted that the data center business is exceptionally hot. This points to a change that is already underway in AI infrastructure. In the past, the market's biggest concern was whether there was enough compute power and enough GPUs. But now a new question has emerged. Can all these GPUs, CPUs, memory modules, switches, and data centers actually be connected together with true efficiency? So today, using Marvell's latest earnings report, we will tackle three critical questions. First, why has connectivity become the key bottleneck for AI data centers? Second, what exactly do we mean when we keep hearing the word connectivity? Is it chip-to-chip, server-to-server, or data center to data center? And third, why is NVIDIA willing to expand its partnership with Marvell and let it plug into its own AI infrastructure ecosystem? Don't they have a competitive dynamic of some kind? By understanding these three questions, we can not only grasp the logic behind Marvell's rally, but also truly make AI infrastructure tangible. IT is no longer just about abstract concepts like compute power and large models. IT comes down to a very real-world problem. How do you actually connect chips to chips, servers to servers, and data centers to data centers? Let us first look at the scorecard Marvell delivered for the first quarter of fiscal 2027. This report actually demonstrated very strong market momentum. In Q1, Marvell's total revenue hit a record $2.418 billion, up 9% sequentially and up 28% year-over-year. More critically, within that $2.4 billion in revenue, the data center business accounted for the absolute lion's share. Data center revenue reached $1.83 billion, representing 76% of total revenue. 76% is an incredibly important ratio. IT tells you that Marvell is no longer the traditional diversified semiconductor company it used to be. IT has transformed into a firm driven by data center and AI infrastructure. However, the most eye-catching part was not the current quarter's data, but the forward guidance given by management. What Wall Street truly cares about is always the future. Management guided total fiscal 2027 revenue to approximately $11.50 billion. That figure implies nearly 40% annual growth. But what is even more staggering is that their expectation for fiscal 2028 was further raised to $16.50 billion. In other words, after a year of almost 40% growth, the following year is expected to deliver another roughly 45% increase. That is the truly mind-blowing part. Every day people debate whether AI demand will cool off or whether the AI bubble will burst. Yet Marvell's guidance paints a picture of completely opposite, accelerating momentum. Even more noteworthy is that the $16.5 billion figure is a full $1.5 billion higher than the outlook they gave just 1 quarter ago in the semiconductor industry, which is asset heavy and requires capacity planning far in advance. A raise of this magnitude is never something management simply cooks up out of unilateral optimism behind closed doors. This kind of rapid-scale expansion suggests that Marvell's orders have likely already been locked in with real money by those hyperscale data center customers, the tech giants. So why are these mega customers so urgently in need of the connectivity that Marvell provides? The answer lies in a fundamental shift happening in the underlying architecture of AI. That we used to think that the AI bottleneck was simply about acquiring more compute chips. But now the real bottleneck is becoming how these chips actually communicate with each other. That is the core logic management has been emphasizing over and over. The compute paradigm of AI has already changed. In the past, we were mostly in a phase of one-shot inference, a single question and answer exchange, and then it was done. Now AI is accelerating into the era of agentic AI, with the underlying architecture increasingly adopting mixture of experts, commonly known as MOE.to. Put it simply, you can think of a mixture of experts model as a committee made up of many specialists instead of a single, giant superbrain. When you give an AI agent a complex task, for instance, asking it to write a piece of code and then run a security test, the system does not commandeer every GPU to compute the exact same thing. The IT routes different subtasks to different expert modules inside the model, and those modules may be distributed across different GPUs, different servers, or even different clusters. The benefit of this approach is obvious. It drastically saves compute and energy. The cost, however, is enormous, because data must be routed and passed among completely different chip clusters hundreds or thousands of times at high speed. It is like having a team composed entirely of top-tier geniuses, each a master of a different domain. But if the office phone lines are cut, or they can only communicate through a sluggish fax machine, they will never be able to collaborate on a complex project. The brain power of those geniuses gets wasted entirely on waiting. To break through this communication bottleneck, data centers need very specialized networking equipment. That is why Marvell's interconnect business is seeing explosive demand. In its earnings release, the company noted that it originally expected its interconnect business to grow about 50% in fiscal 2027, but management now directly raised that forecast to over 70%. This is an extremely strong signal. More importantly, Marvell is not betting on just a single technology node. If you look at the strategic layout revealed in the earnings report, you will see that it has very clear positions across the 3 core layers of AI data center network connectivity. The first layer, which is also the most ferociously contested battlefield, is scale-up. This solves the problem of how different GPUs and custom chips engage in extremely dense, extremely high-frequency direct dialogue inside a single machine, or even within a chip package of just a few square centimeters. It is a microscopic battlefield of ultra-short distance yet terrifyingly massive data throughput. The second type is scale-out. This addresses how hundreds or thousands of racks and rows of servers inside the same data center interconnect at high speed. You can picture it as how different racks and servers connect inside a giant warehouse. The third layer is scale-across, which is cross-data center expansion. This corresponds to Marvell's data center interconnect business, primarily DCI modules. DCI stands for Data Center Interconnect. Why is this so important? Because today's AI compute clusters are so large that a single data center may not have enough power, cooling, or physical space. One campus simply cannot fit everything, nor can it supply enough electricity. So hyperscale cloud providers must distribute a portion of their compute resources across different buildings, different campuses, or even multiple data centers. But AI workloads are not just ordinary data backups. They require continuous transfer of huge volumes of data between data centers with latency as low as possible, bandwidth as high as possible, and power consumption that cannot be absurd. That is the value of DCI modules. The earnings report mentioned that Marvell's coherent optical products mainly target connectivity applications in the 2 to 20 kilometer range. The goal is not to literally plug those distributed servers into the same motherboard, but to minimize the latency and bandwidth penalty introduced by cross-data center transmission, making the geographically dispersed AI clusters behave more like a unified system. This also explains why the DCI business is becoming a high-growth market that is rapidly evolving from 400G and 800G to 1.6T that the company has already stated that by fiscal 2028, it sees a clear path for the DCI module business alone to reach a $1 billion annualized revenue run rate. After explaining these three layers of connectivity, you can understand why Marvell made two acquisitions in the first quarter, Priorion and Celestial AI.at their core. These two acquisitions are not independent technology bets. They are meant to add the next-generation optical interconnect capabilities across these three connectivity layers. Priorion corresponds more directly to scale across. The DCI and coherent optics product line. IT brings plasmonic photonics technology. The earnings report noted that its modulator bandwidth has already exceeded 1 terahertz. That terahertz is not a transmission speed in the usual sense, but the bandwidth capability of the modulator, aimed at preparing for future 3.2T and even higher rate optical transmission. Celestial AI leans more towards scale-up. IT brings photonic fabric technology. This concept points to the most cutting-edge trends in advanced packaging and optical interconnects, CPO and NPO, co-packaged optics and near-packaged optics. IT solves the problem of how to transmit data with shorter reach, higher density, and lower power near XPUs, switch chips, and the package SO. These two acquisitions are essentially one far and one near. Priorion targets longer distance, higher speed data center interconnects. Celestial AI targets optical interconnects closer to the chip and inside the package. Together, they tell a single story. Marvell has concluded that the connectivity bottleneck in future AI data centers cannot be solved by traditional electrical connections alone, whether near the chip, between servers, or between data centers. Optical interconnects will become increasingly critical. Of course, optical interconnects are not a brand new concept. Plenty of startups have told similar stories on PowerPoint. But Marvell's edge is that it has already shipped over 1 million silicon photonics-driven DCI modules and accumulated more than 15 billion hours of field operation data across its fourth-generation silicon photonics deployments. This is not a lab demonstration. It is reliability proven in real data center environments. Precisely because of this foundation, Marvell has the ability to truly integrate these cutting-edge acquisitions into its three-layer connectivity architecture of scale-up, scale-out, and scale-across. This is a time moat that startups will find extremely difficult to cross. The earnings also discussed Marvell's custom silicon business. This business does not only serve the scale-up tier. It also includes an entire suite of custom chips and companion chips built around AI accelerators, such as XPUs. The custom main chips, as well as XPU tiles, the connectivity chips surrounding the XPU, plus NCs, network interface card chips, and CXL memory connectivity chips. The company believes this business has the potential to surpass the $10 billion mark by fiscal 2029. That is an astonishing scale. Of course, any mention of custom silicon architecture inevitably brings to mind the current undisputed king of AI, NVIDIA. In this earnings report, Marvell dedicated significant space to expanding its partnership with NVIDIA. They are collaborating on optical interconnects, NVLink Fabric, and AI RAN. At first glance, this looks rather strange. We all know that NVIDIA's most famous business strategy is to build an incredibly powerful ecosystem. Its GPUs, networking, software, CUDA, and NVLink ultimately form a highly integrated, sticky system. So the question is, why would NVIDIA make it easier for Marvell's custom chips and networking silicon to plug into NVIDIA's own infrastructure? Is that not handing ammunition to potential competitors and weakening its own moat? Looking at the bigger picture, this actually touches on a very delicate psychological game among tech giants. Put yourself in the shoes of a hyperscale cloud provider like Microsoft, Google, or Amazon. Would you ever be willing to have the lifeblood of your AI infrastructure permanently locked in by a single hardware supplier? The answer is absolutely not. That is precisely why these giants are furiously pouring money into developing their own custom AI chips. Nobody wants to work for NVIDIA forever, but the real-world dilemma is that the industry's most advanced, most efficient system network architecture still resides in NVIDIA's hands. So cloud providers find themselves in a bind. They want to use NVIDIA's powerful system network, yet they also want to develop their own custom silicon. If these different architectures cannot talk to each other efficiently, the performance of the entire system suffers. This is where Marvell's role becomes critical. It acts like a neutral, super smart universal adapter. With Marvell's integration technology, a cloud provider's own custom silicon can potentially plug into NVIDIA's NVLink Fabric much more smoothly. And why would NVIDIA agree to that? The reason is that if NVIDIA leaves its customers absolutely zero flexibility, certain hyperscalers might completely defect to other open ecosystems or even start building their own alternative from scratch. If that happens, what NVIDIA stands to lose may not just be a small opening in its interface, but control over the entire system standard. So through a neutral bridge like Marvell, NVIDIA appears to concede a small step, yet in reality it makes those hesitant customers more willing to stay inside its own ecosystem. This is an extremely clever, open strategic masterstroke. Cloud providers get more flexibility. NVIDIA preserves its system standard, and Marvell feasts on the astonishing incremental spoils in the middle. As for AI RAN, it represents the direct integration of AI with 5G. And potentially with future 6G wireless communication hardware. It signals an important potential evolutionary path. As agentic AI proliferates, AI will no longer be concentrated solely inside giant data centers. It will gradually spread into the global telecommunications network, all the way to the edge of the network. In other words, future AI infrastructure will not just be the GPUs inside data centers. IT will increasingly embed itself into communication networks, edge nodes, and radio access networks. But after covering the technology roadmap, we still need to face a more practical question. Can Marvell actually deliver all these products? The hardware industry is not like software, and no matter how beautiful the PowerPoint slides are, if you cannot secure advanced process nodes, advanced packaging, and critical material capacity, it all just remains a story. That is why there is one important detail in this earnings report. Marvell plans to pay roughly $1 billion in prepayments to its supply chain in fiscal 2027 to lock in future production capacity and material supply. This tells us two things. First, customer demand is not just talk. It is already strong enough to force Marvell to preemptively grab supply chain resources. Second, Marvell's competitive edge is not just about technology, but also about its ability to deliver. Many startups might have fantastic optical interconnect concepts, but when it comes to the massive deployment phase in real AI data centers, customers are not looking at PowerPoint. They are looking at who can mass produce reliably and deliver on time. The earnings report also noted that Marvell's operating cash flow in Q1 reached a record $639 million. It is precisely this kind of cash flow strength that gives it the confidence to lock in capacity ahead of time. Marvell's earnings report was not just about telling a growth story, that IT was also telling the market. It has the orders, it has the technology, and it has the supply chain capability to turn that technology into real revenue. To sum up, today we have not only understood the Marvell earnings report that points to a fiscal 2028 revenue target of $16.50 billion, but more importantly, we have witnessed an underlying migration happening in AI infrastructure. In the coming AI era, the speed of data movement is becoming the absolute ceiling that determines AI computing capability. Even if a server is stuffed with the most expensive GPUs, if the network connecting them is congested, it all amounts to nothing more than a pile of costly, heat-generating hardware waiting for data. For more and more high-speed connectivity links using optical signals in place of traditional electrical signals, to ultra-high bandwidth switching between racks, and then to high-speed cross-data center interconnects. The battleground of AI infrastructure has already expanded from pure compute into the connectivity layer. Whoever can dominate that connectivity layer will likely seize an increasingly pivotal position in the next stage of AI infrastructure competition. And that is precisely why Marvell's data center business is running exceptionally hot right now.